everybody. Today I want to talk about simplifying, multiplying, and dividing rational expressions. So we're going to be doing some thinking, so get yourself some paper and pencil, because when you think you should be writing, and when you're writing, let's definitely think. So let's talk about rational expressions first. What is a rational expression? A rational expression is a ratio, or maybe a fraction, if you like that better, of two polynomial expressions. What is that? Well, it's something like this. So x squared plus 7x plus 12 divided by x squared minus x minus 20. That would be an example of a rational expression. But don't let the fractions scare you. Okay, it's just it's got a numerator and a denominator, just like a fraction that you're used to seeing, say, maybe in 4th or 5th grade. But before we multiply and divide them, we first have to know how to simplify them. How do you reduce fractions? Now, this is a mistake, but I'm about to show you. Students will come through here and they'll go, oh, look, I have an x squared there and an x squared there, and those cancel. No, they don't. And the reason they don't is because division doesn't cancel things that are added or divided. Division only cancels things that are multiplied. Only factors will cancel. So, for example, if I had 5 plus 6 all over 5 plus 7, you should know that you can't come through here and cancel the 5 and the 5 and call it 6 sevens, right? But if it was 5 times 6 divided by 5 times 7, now you can. Because division is the opposite of multiplication. It's not the opposite of addition or subtraction. So you can't cancel individual pieces that are added or subtracted, but you can cancel things that are multiplied. So before we do that with some algebra expressions, let's talk about how you would do it if you had just a simple number that you're familiar with. So let's go back to maybe 4th grade and let's think about something like 15/21. And let's reduce that fraction. Now you may think, hey, divide top and bottom by 3 and then we get an answer. And you would, if you did it that way. You would say 15 divided by 3 and that's going to be 5. And then you're going to say 21 divided by 3, that's going to be 7. And yes, 5 sevenths is your answer. But dividing top and bottom by the same number is not really helpful when you're doing algebraic expressions. So really what I want you to focus on is canceling common factors. So let's fully factor 15 and let's fully factor 21. So that would be 3 times 5. And then 21 is 3 times 7. Now, is the 3 being multiplied? Yes, it's being multiplied in each case. So when I say top times 3 and the bottom divide by 3, I can cancel those. Really what I'm doing is this. I'm separating these two out and I'm saying 3 divided by 3, that's 1. And all I have left then is just 5 sevenths. So that's the method that we're going to use to simplify rational expressions. So for this part here, to simplify rational expressions, fully factor the numerator and the denominator, then cancel common factors. So for this fraction here, what I need to do is I need to fully factor the top and the bottom. And if you need some help on factoring, please go back and watch my factoring videos on my channel. So this is a quadratic. I need to find factors of 12 that when I add them together give me 7. Well, that's going to be x plus 4 and x plus 3. Then I need to find factors of 20 that when I subtract them give me the number 1. Well, that's going to be an x plus 4 also, and then an x minus 5. Okay, now any factor on top can cancel with any factor on the bottom, and now we're talking binomial factors. This x plus 4 group here will cancel with this x plus 4 group. I'm allowed to do that because they're multiplied here in top and bottom. And all I have left then is just the x plus 3 divided by x minus 5. And I can go no farther with that. Don't try to cancel the x's. So if you can remember back to 4th or 5th grade fractions and simplifying those, you can do it with algebra, with numbers that you don't even know. So now let's talk about how we would multiply or divide rational expressions. Let's talk about multiplication. All right, so you recall that when you multiply two fractions together, something like 12/7 multiplied by now 14/3. You can multiply the numerators straight across, 12 times 14, and then 7 times 3, and something 21 down here, and I don't know what that is on top, something huge, something really big. But then you have to reduce it. But if you're savvy have 2 V's or 1 V? Savvy? Maybe it's just 1 V. I don't know. I'm not too savvy with my spelling, actually. But if you're savvy with your math, what you can do is this. You can fully factor the top. 3 times 4 is 12, divided by 7, 7 prime. Multiplied now by 2 times 7, divided by 3. And now any factor in the top can cancel with any factor in the bottom. So this 3 and this 3 can cancel. And then this 7 and this 7 can cancel. And in the end, all I've got is just 4 times 2. So my final answer right there is just 8. Okay, I didn't even have to reduce it at all. And this is the way that you're going to have to do it when you multiply algebraic expressions, because factoring huge algebraic expressions and then reducing them is sometimes next to impossible. So the general rule for multiplying rational expressions would be this, if I do it abstractly. It would be A over B multiplied by C over D. You just multiply the numerator straight across and get A times C divided by B times D, provided that B and D are not 0, because if you have 0 in the denominator, you can't do that. That's undefined. So just multiply straight across, but factor and cancel first. Now, dividing rational expressions, you're going to love this. A times B divided by C, or C over D. Don't. Whenever you feel like dividing one fraction by another fraction, don't. What you want to do is you want to multiply by the reciprocal of the divisor. The second one is the divisor. So I'm going to take it and make it A divided by B, multiplied by D over C. So then I'm going to get AD divided by BC, provided that you simplify first before you multiply those pieces together, right? So never divide by a fraction, multiply by the reciprocal of the divisor. So maybe you memorize something like you're going to keep the first thing, you're going to change the sign to multiply, then you're going to flip the bottom one, something like that. Okay, so let's try some examples here now. Let's simplify this expression right here. Well, in looking at it, it doesn't look too complicated. The top's ready to go. The bottom's not. On the bottom, I need to raise all those things to the fourth. So notice I'm writing my fraction bar first. Now I'm just going to recopy the numerator, 24, 8 to the 5th, b squared. And then I'm going to raise everything down in here to the fourth, because this is a monomial. So 2 to the fourth would be 16, 8 to the fourth, b to the fourth. And now I can simply cancel each coefficient and each variable in its turn. So let me do 24/16. How does that reduce? Well, they both have a factor of 8. So if I factor out an 8 and then cancel that, I'm going to get 3 on the top here and then 2 on the bottom. Okay, done with that one. Now I've got 4 A's on the bottom and 5 A's on the top. I've got more on the top than in the bottom. So all of these are going to cancel, leaving me just a 1 there. Notice I canceled the entire base on the denominator, but I just canceled the exponent in the numerator and kept the base. So I've got 1A left up on top. I'll go ahead and write that in there. Done with the A's now. And then let me do my B's. Hey, I've got more B's on the bottom, so all of these will cancel with 2 of these, leaving me 2 remaining. So B squared then on my denominator, and that's it. There we go. If you reduce kind of as you multiply, you don't have to reduce later. So let's move on now to the next one. This one was a monomial. Now let's do something where we multiply. Okay. I don't see anything that I can simplify first. It's multiplication right here. So basically what it's doing is I can just think of this as like a continual single fraction bar. And it's multiply, 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 multiply. Okay. That might get a little awkward with all the parentheses, but anyway. I'll do it like this. I'm going to start in the front end. I'm going to start on the left, and I'm going to the 3 here, and I'm looking for anything that the 3 will cancel with. We'll cancel with this 9 over here. because it's multiplied. So how did the 3 and the 9 cancel? This leaves me a 1, this leaves me a 3. Now I'm going to move on to the r squared. Do I have any r's on the bottom? Yes, I do. I've got an r cubed right there, and there's more on the bottom. So all of these are going to cancel, leaving me just one of those. Notice I didn't write the 1, it's just there. It doesn't have an exponent. When it doesn't have an exponent, it's 1. Now move on to the n's. I've got 3 n's on top, n cubed. Do I have any n's on the bottom? Yes, 1 right there. So one of those will cancel, leaving me 2 of these remaining. Keep going, go to the 20. Will 20 divide by anything on the bottom? Yes, divide by that 5. That's going to leave me a 1. Cancel this. That's going to leave me a 4. And then the t's. I've got t squared on top and t to the 4th on bottom. All of these are going to cancel, leaving me 2 down below. And now I just come straight across with the pieces that remain. What have I got remaining? Number-wise, well, the 1 doesn't do anything for me here, but I've got 4. So I've got a 4 on top here. Any other numerator parts? Looks like an n squared that I've got right here. And I think that's all for my numerator. What's my coefficient in the denominator? Well, I've got a 3 right here, so a 3 in the denominator. And then I've got a t squared here, and then I've got an r right there. But it's customary to write these in alphabetical order, so t doesn't come first, r does. So I will simply rearrange those orders there. That's going to be an r t squared. So in the end, 4n squared over 3rt squared. There's my answer. One little small step at a time. Don't try to do it all at once. Now, let's talk about C. Whoa, don't panic. Okay, small steps. The first thing I notice is that it's division. So I'm never going to divide one fraction by another one. I'm going to multiply by the reciprocal of the divisor. The second fraction is the divisor. So I'm going to flip this one over. And I'm going to work down now so that you can see how one fraction kind of becomes another one, or what the progress is there. I'm just going to recopy x squared plus 8x plus 16, and on the bottom 2x minus 2. Now change the operation to multiply, and then flip this fraction over. X minus 1 on top, and then x squared plus 2x minus 8 on the bottom. I did not try to factor that simultaneously. I didn't even try to factor it first. The first thing I did was I changed it to a multiplication problem, and that's what I recommend that you do. I've seen a lot of students, and sometimes even myself, I get so focused in on factoring everything that I forget that it's a division problem, and I don't flip the divisor. So flip the divisor first, then as a separate step, go back through and factor everything. So let me fully factor the numerator on the left. Factors of 16 that when I add them give me 8. That would be 4 and also 4. Oh, that means it's a perfect square. It's going to be an x plus 4 quantity squared. Now, factor the 2 out of the denominator. 2 times x minus 1 times x minus 1. Maybe even put parentheses around that so you realize it's a group. And then factors of 8 that when I subtract them give me 2. That would be a 4 and a 2, so an x plus 4 and an x minus 2. Extend my fraction bar there. Okay, now, any factor on the top can cancel with any factor on the bottom. I've got an x plus 4 squared, which means I've got 2 of them. So one of these will cancel down here, leaving me 1 on the top. And then the x minus 1 right here will cancel with that x minus 1, and I think that's it. So what have I got now as my final answer? So I've got an x plus 4 divided by a 2, don't forget that guy right there, times x minus 2. And I wouldn't bother to multiply the 2 into that group, just leave it like that. There's no advantage really to multiplying that in. Okay? So if you take it bit by bit, multiply by the reciprocal of the divisor, and then you're going to factor all the pieces and cancel the common factors. There you go. Now, what happens if you don't cancel everything first? If I were to actually not cancel and take x plus 4 squared, or let's do it up here on this one. If I were to take this group here times that group there, I get something outrageously large, like x cubed plus blah, 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 minus 16 in the end, and then I'm going to multiply these two together like this. That would be something outrageously huge, and then you have no idea how to factor it. right? So you can't reduce it. No, it's not a good idea to multiply first and then reduce. Factor, cancel, then multiply your pieces together. All right, D. Don't flip out. You're like, oh no, like fractions galore. No, don't flip out, but do flip the denominator, right? Because isn't this a division question? Look, I'll show you this right. This is the big division sign. Isn't it just this top fraction divided by this bottom fraction? Yeah, so it's just a division problem. Don't flip out, flip the denominator. So my numerator stays the same, x squared minus 9 all over 4. And I'm going to now flip the denominator, x, no, sorry, I'm looking in the wrong spot, 8. And then 3 minus x. Now it's not so bad. Let me fully factor everything. So the top is a difference of squares, so that gives me conjugates, x plus 3 times x minus 3. The bottom is just 4, that's nice and handy. Top is just 8, that's nice and handy. I bet that 4 and that 8 are going to play well together. And then, this is not exactly what I want. I don't want 3 minus x. I really want this one. I want x minus 3. And if you think about it, if I factor out a negative from the bottom, it gives me an x minus 3. There we go. Now, any factor on the top can cancel with any factor on the bottom. Obviously, this x minus 3 here with this x minus 3, and then this 8 is going to cancel with this 4, leaving me a 1 down below and a 2 right there. And I think that's everything that I've got. So now come straight across with the pieces that remain. I'll leave it as a 2 times the x plus 3 divided by, and it's just going to be the negative times the 1 right here. So negative 1. That's a little obnoxious just to have the denominator of negative 1. Let me take the negative and move it up to the top. So long as there's only 1, I can do that. So it's negative 2 times x plus 3, and then the denominator is now just positive 1, which is positive 1. I don't even have to write it. So there we go. Here's my answer. All right. So if you can think about the methods that you used in 4th and 5th grade math, the basic fractions, you can do that now with fractions, and you don't even know what the numbers are. What if your 4th grade teacher told you one of these days you're going to do fractions and you're not even going to tell you what the numbers are? That's algebra. There we go. Same rules still apply though. The numbers are still just numbers. Anyway, I hope you have a great day, and I'll talk to you later. Bye-bye.